Hello and welcome. Last time we discussed matter and explored some of its characteristics. Today we will continue exploring the property of matter. The third property would be melting. So we know that matter exists in three states: solid, liquid, and gas. And matter can change from one state to another. For example, it can change from a solid state to the liquid state in a process called melting. So melting is the change of matter from solid to liquid. But that doesn't happen instantly. It takes time to matter to heat up and reach a certain temperature at which it starts melting. So if we have a cube of ice and we put it in a room temperature, the ice will keep heating up until it reach 0 degrees Celsius and then start melting. So we call this temperature melting point. So the temperature at which the matter begins to melt or begins to change from solid to liquid is the melting point. So what is meant by the melting point of ice is 0 degrees Celsius. We say that means that the ice will start to change from solid state to a liquid state at 0 degree Celsius. So the ice begin to change into water at 0 degree Celsius. So does all matter have the same melting point? Let's see. So here we have a piece of chocolate and we will heat the chocolate at a melting point of 35 degrees Celsius. So let's try aluminum, heat. Aluminum at a very high melting point, 660 degrees Celsius. Let's try ice, will heat, melt at 0 degrees Celsius. So the ice melt at 0 degrees Celsius, a lower melting point than both chocolate and aluminum. So the wax had 60 degrees Celsius melting point. So from this experiment, we know that each substance has a defined melting point. If every matter has its own melting point. So we have substance which has a low melting point like ice, wax, and butter. Other substances have high melting point like iron, copper, aluminum, and table salt. Then boiling. Boiling is the change of matter from liquid state to a gaseous state. So boiling is the change of matter from liquid state to a gaseous state by heat, and also doesn't happen instantly. The matter keep heating until it reach certain temperature. We call it boiling point. So the temperature at which the matter begins to boil or change from liquid to a gas, we call this boiling point. And each matter has its own boiling point. So what is meant by the boiling point of water equal 100 degrees Celsius will mean that boiling point mean the degree or the temperature at which the water will start change from liquid to gas equal 100 degrees Celsius. And we use this idea of that every matter, each matter has its own boiling point to separate the crude petroleum by heating to its component, because each of the petroleum component has its own boiling point. So the crude oil will go into the furnace, heating up. Each of its component will boil at different temperature. Then we have the hardness. Hardness means how malleable the substance is, how easy to change, how easy to control the matter and to change its shape. So with solid substance, we divide it according to hardness into solid substance are soft at room temperature, like rubber. Other solid substance can be softened by heat, like metals. Other substance can't be softened by heat, like coal and sulfur. So why the screwdrivers are made of steel iron? Because iron is very hard. Why the rod used in building houses are made of iron and not the copper? Because the hardness of iron greater than the hardness of copper. Because the hardness of iron more than that of the copper. So then we have electric conductivity. We studied part of this last year when we differentiate the material into good conductor of electricity and bad conductor of electricity. So the good conductor of electricity is the substance that allow electricity to flow through, like metals, iron, silver, copper, and aluminum. Some solution, like acidic solution, alkaline solution, and some salt solution. And we have bad electric conductor or insulator, which are the substances that don't allow electricity to pass through. Some solution, like solution of hydrogen chloride in benzene, and sugary solution. And some solid, like plastic. Here we have salt. We put the salt in the water. And we put the lamp. The lamp will light because salt conduct electricity. So let's remove the salt and put sugar. Let's repeat. The light didn't turn on because sugar solution don't conduct electricity. So if we this eraser, the bulb didn't light because the object, eraser or rubber, doesn't conduct electricity. Let's change with the key. The light turned on because the key or metal conduct electricity. So the chuck won't light. The rubber duck battery will allow the bulb to light. The wire, which is made of copper. So why electric wires are made of copper and aluminum but covered with a plastic? Because copper and aluminum are good conductor of electricity, but plastic are bad conductor of electricity. Why the electric screwdrivers are made up of steel and has their hand made of wood or plastic? Because copper or steel are good conductor of electricity, but the plastic and wood are bad conductor of electricity. Then thermal conductivity. We studied that we divide matter into two: good heat conductor and bad heat conductor. Good conductor of heat allow heat to flow through, like metal, iron, copper, and aluminum. Bad conductor of heat material that won't allow heat to flow through, like wood and plastic. And that's why we make the cooking pans of aluminum, stainless steel, or iron, while we made the handle of them from wood, because aluminum is a good conductor of heat and has high melting point, but wood and plastic are bad conductor of heat. And that would be the all physical property. Next, we'll have the chemical property. We divide the metal according to their chemical activity into very active metal. Their metal will react with oxygen instantly, like sodium and potassium. And less active metal, it takes time for them to react with the oxygen, like iron, when it forms the iron rust. And inactive metal that poor activity, that don't react easily with oxygen, like gold and silver. Here a question. Why sodium and potassium are kept under a kerosene surface? Let's see.
Straight out. I just probably threw it that way, huh? All right, ready?
2, 1.
Oh! Oh! Oh!
That's why. To prevent the reaction with oxygen. So we keep sodium and potassium under a kerosene surface to prevent their reaction with oxygen. Steel bridge and the holders of light painted from time to time. We paint them to cover them, so we prevent them from reaction with oxygen to protect them from rust and corrosion. Metallic spare parts of cars are covered with grease, also to prevent the reaction with oxygen to protect them from corrosion. Aluminum cooking pans are washed through rough material to remove the rust layers. Silver, gold, and platinum are used in making jewels because they are poor chemically active, so they won't react with oxygen because they are chemically poor active. Nickel, gold, and silver are used to cover other substances such iron, because nickel and gold, silver are poor active, so they prevent or protect the iron from rust.